Take note of the following examples concerning a power or an exponent of 0. We have that whole bracket, 2x plus 3y squared minus 4z to the power of 3, but the whole bracket is equal to 0, so the whole expression just becomes equal to 0. The same with the second one, m to the power of 12, n to the power of 342, all inside a bracket, to the power of 0, still remains just 1. Same with 85, a normal number, to the power of 0, still stays 1. So any expression to the power of 0 always equals 1. Now if we observe the second law of exponents, which is that, basically saying if we divide two terms, a to the power of m divided by a to the power of n, we can simply subtract the two exponents from one another. Now it is always a good idea to subtract the bottom from the top exponent. It's just a good rule of thumb to remember, subtract bottom from top. But it may create the following situation, as you can see there. We've got x to the power of 3 on top and x to the power of 2 at the bottom. So if we subtract 3 minus 2, we get x to the power of 1. That's still fine. But if we look at the y, we've got 4 on top and 6 at the bottom, and 4 minus 6 will actually give us a minus 2 exponent. So we notice that now we are working with a negative exponent, and we have to define a rule for working with negative exponents. You will notice from this example that had we not decided to subtract the bottom exponent from the top, referring to that one, if we rather decided to subtract the top from the bottom, we would have had y squared under the line or below the line, because then it would have been 6 minus 4 below the line, and then we would have y squared instead of y to the power of minus 2. Which effectively means y to the power of minus 2 is the same as 1 over y to the power of positive 2. So the negative exponent just goes to the bottom and becomes a positive exponent. So the rule that we were referring to is the following. A to the power of minus n is equal to 1 over a to the power of positive n. As long as a remains a real number, in other words it must exist, can't be a non-real number, and it cannot be equal to 0. Because remember, you cannot have a 0 below the line. So those are the two exclusions, but other than that, as long as it's a real number not equal to 0, this rule for negative exponents would hold. So we've also got examples there. A to the power of minus n, a over b to the power of minus n, we can just simply swap the two around. The a goes to the bottom, the b goes to the top, and it actually gets a positive exponent. So what this means is that any fraction with a negative exponent swaps around to become a fraction with a positive exponent. Again, a must be a real number, and a cannot be equal to 0 because it's below the line, and in the first case there, b is also below the line, so that cannot be equal to 0 either. Or we could have 1 over a to the power of minus n. So now we are already at the bottom with a negative exponent. What happens in this case is simply that. It just goes to the top and becomes a positive exponent. So remember, the negative exponent actually makes a fraction. But if you already have a fraction, which it says there, that has a negative exponent in the denominator, it just becomes a normal term, again with the same constraints, and then just look at some examples. 3 to the power of minus 4 becomes 1 over 3 to the power of 4, which is 3 times 3 times 3 times 3, 4 times 1 over 81. Then we look at example number 2, where we have 3/4 to the power of minus 2. Remember, we said they swap around and it becomes a positive exponent. 4 squared is 16, 3 squared is 9, and then number 3, 1 over 2 to the power of minus 3. It just becomes 2 to the power of 3, which is equal to 8. Now remember, a mixed number must first be converted to an improper fraction before it may be raised to a power. For instance, if we have 1 1/4 to the power of 2, we need to make this 5 over 4 to the power of 2 first, and then we can make it 25 over 16. Just something that you need to remember when working with exponents and fractions, whether it's a positive or a negative exponent.